You breathe slowly, letting your body sink into stillness. Around you, the room is quiet, but in your mind, a universe unfolds. You drift backward through time, far beyond memory, beyond history, beyond even the birth of stars. You drift toward a beginning, the moment when everything was new, the Big Bang, the first breath of the cosmos. In that instant, space itself opened, light filled the void, and energy swirled into being. Out of that energy, particles were born. But they did not arrive alone. Each particle came paired with a shadow, a twin antimatter. You imagine them now, tiny sparks of creation, electrons paired with positrons, protons paired with antiprotons, neutrons paired with antineutrons. Each particle a mirror of its partner, the same in weight and spin, opposite in charge. Together, they form a perfect balance, a symmetry so elegant it feels like poetry written into the laws of nature. Matter and antimatter, twins born of the same breath, destined to meet, destined to vanish. You breathe into the rhythm of their dance. When matter and antimatter touch, they do not fight. They dissolve into pure energy, light streaming outward, annihilation, yet not emptiness. From their destruction comes creation. From their vanishing comes radiance. In those first moments, the universe was filled with these dancers, particles meeting their twins, disappearing into photons, flooding space with light. It was a sea of balance, a cosmos of symmetry, where matter and antimatter existed as equals. And yet, you look around your world tonight, you see stars, planets, oceans, mountains. You feel your breath, your body, your mind, alive. All of it is made of matter, not antimatter. The symmetry was broken. Somehow, in those earliest moments, matter gained a tiny advantage. For every billion pairs of matter and antimatter, there was one extra particle of matter left behind. And it is from those survivors, those few, those fragile remnants, that everything you know was built. You pause, letting this truth settle into you. All of existence, every tree and stone and star, is built from imbalance. The symmetry was almost perfect, but not quite. A tiny preference, a small excess of matter, tilted the balance of the universe. Without it, there would be no galaxies, no planets, no you. Only light, endless and empty. You drift deeper into thought, picturing the symmetry as a mirror. On one side, matter shines. On the other, antimatter reflects. For a moment they are equal, a flawless balance. But then, the mirror cracks. The reflection fades. One side remains, the other vanishes into history. Scientists still wonder why. Why did matter win? Why was symmetry broken? The laws of physics, as we know them, treat matter and antimatter the same. And yet the universe chose matter. The mystery lingers like a question whispered across time. You breathe slowly, not seeking answers, only resting in wonder. Sometimes, mysteries are not puzzles to be solved, but lullabies to carry you deeper into stillness. Picture the first second of the universe, less than a heartbeat, yet filled with creation. Space expanded faster than light, stretching, cooling, birthing particles from pure energy. For a brief moment, the cosmos was a furnace of balance. Matter and antimatter surged, collided, vanished into photons. Yet with each wave of annihilation, a few particles of matter remained. Slowly, their presence grew. Slowly, they became the seeds of everything that would come. You imagine those survivors as sparks in a dark sea, drifting through annihilation, glowing faintly with persistence. They carry within them the future, stars to ignite, galaxies to spin, planets to form. Within them sleeps the possibility of oceans, forests, and living beings that one day look up at the stars and ask how it all began. And here you are, resting now, breathing in the quiet of night, your body itself built from those ancient survivors. Every atom in you, the carbon in your cells, the oxygen in your lungs, the calcium in your bones, all of it is matter left behind when symmetry broke. You are the child of imbalance, the heir of that tiny excess, the living proof that imperfection creates possibility. You let this realization soften you. Perfection may be beautiful, but it is imbalance that gives rise to life. The broken symmetry of the universe is the reason you exist. The night deepens, and you drift into the vastness of time. Billions of years stretch between you and that first second. Galaxies formed, stars lit, planets spun, life arose. Yet all of it rests on that fragile beginning, that moment when shadows were born, met, and mostly vanished. What you see now, the stars above, the earth beneath, is the echo of those shadows. You breathe into the calm of paradox. Matter and antimatter were born as equals, destined to vanish in light, but a trace remained. The universe, you know, is not the full balance, but the remnant, the survivor, the shadow of a shadow. And in that shadow, you live, you breathe, you dream. The chapter slows, inviting you to rest in this thought. The story of antimatter is not only physics. It is a story of balance and imbalance, of symmetry broken, of creation through destruction. It is the story of how everything you know came to be, born from twins that could not survive together. You breathe deeply, carrying with you the memory of beginnings, the instant when matter and antimatter were born together. Twins in perfect balance. The story continues now, unfolding in the quiet rhythm of mirrors. For nature, in its elegance, seems to love symmetry. And nowhere is this more apparent than in the pairing of particles with their opposites, the mirror twins of existence. Close your eyes and imagine the smallest pieces of the universe. Protons, neutrons, electrons, the building blocks of everything you know. Each of them has a shadow twin. For every electron, there is a positron, equal in mass, opposite in charge. For every proton, there is for every neutron, an anti-neutron. It is as though the universe held up a mirror at creation, and every particle saw its reflection. This is not symmetry in the vague sense of beauty or balance. It is symmetry written into the laws of physics. To scientists, it is called charge parity symmetry, a rule that suggests particles and their twins should behave the same, except with opposite charge. You drift into this image, a hall of mirrors where particles dance with their reflections. They move alike, they spin alike, they share the same weight. Only their charges differ, one positive, the other negative. This is nature's poetry, a balance so precise that it feels like perfection. And yet, you breathe into the paradox. If the symmetry is so perfect, why did matter survive and antimatter vanish? Where did the balance break? The mirror shows two sides, but only one remains in your world. You imagine touching the glass of this cosmic mirror. On one side, you feel the matter of your own body, the atoms in your hands, the molecules in your breath. On the other side, you sense the antimatter that should exist but does not. The reflection is haunting, beautiful, incomplete. Scientists spend their lives exploring this mirror. They trap antimatter in magnetic fields, studying its movements. They create positrons in laboratories, watching how they dance with electrons. They compare each reflection, searching for differences so small they are almost invisible. The hope is that in the cracks of symmetry lies the answer to why matter won the universe. You pause here, breathing slowly. Imagine two identical books placed side by side, one written in ink, the other in light. They tell the same story, page for page. And yet, in one line, one word is missing. That absence changes the ending. Matter and antimatter are like those books, identical in nearly every way, but with some secret difference that reshaped the universe in your mind. You see the pairs, electrons and positrons, protons and neutrons and antineutrons. When they meet, they vanish into light. But when they are apart, they endure. The symmetry is delicate, two sides of a coin, spinning in cosmic balance. You rest in this thought. The universe is not random chaos, but patterned, mirrored, ordered. It is built with twins, as though nature sought to balance itself at every scale. Even within atoms, electrons orbit nuclei in mirrored shells. Even in galaxies, spirals turn in symmetry. The mirror twins of matter and antimatter are part of this greater harmony. Even if the harmony feels broken now, the night deepens as you linger on this image. You drift through a hall of cosmic mirrors, each one reflecting a particle and its twin. The reflections shimmer, glow, and vanish. The silence is not empty. It is filled with the weight of mystery. Why does the mirror feel incomplete? Why does one side remain? The answer is not yet known, but the search continues. And in the search lies wonder. You breathe deeply, letting this curiosity cradle you. Sometimes the mystery is more soothing than the solution. To rest in the mirror's glow is enough. The chapter slows, inviting you to imagine yourself as both matter and shadow. A child of balance, existing in a universe tilted by the slightest imperfection. The mirror twins remind you that even in brokenness, beauty remains. You breathe in slowly, letting your chest rise like a small tide, then fall again. Tonight you walk a corridor of invisible encounters, where things meet and do not bruise, where touch becomes light, where an ending is not a wound but a widening. The corridor is short and sudden. It lasts less than a heartbeat and more than a lifetime. In that briefness, two partners matter and antimatter find each other, and in finding, they vanish. You picture them as specks on opposite shores of a small, expanding sea. One is you ward, the other you away. Same mass, opposite charge, two notes that cancel, two silence. They do not hate, they do not love, they obey. The universe has written a sentence in its earliest grammar, and this is one of its verbs: annihilate. But even that word misleads, because what follows is not nothing. What follows is light. You imagine an electron gliding through an atom-thin alley of space. Its electric field like a soft aura. Somewhere nearby, a positron floats through its own quiet, drawn as if by memory toward its twin. There is no plan here, only probability, the way pollen meets water, the way two snowflakes cross on a winter breath. They approach. The fields swell. The air between them tenses like a string about to sing. Then the string is plucked, electron and positron touch, and their masses unspool into photons, the pure currency of radiance. No debris, no crumbs, just brightness that carries momentum away as if shouldering a shared story into the distance. You rest in the physics of the moment, not as a list of terms, but as a feeling. Mass is a kind of stored possibility, a coil of energy slowed into shape. When the mirror twin arrives, the coil loosens and the energy stands up again as light. E equals mc becomes not a formula, but a doorway. You step through and find that what you called thing can become beam, and nothing precious is lost only. The coat has changed, and the traveler continues. In the early universe, this happened everywhere. The cosmos was a fever of meetings, 1,000,000 trillion drifts and touches per breath. The newborn sea fizzing with annihilation like a cosmic sparkler. You listen for that fizz now. You imagine the white hiss of an untuned radio, and you let it be a ghost of those first collisions. The hiss is not pure poetry, faint relic, light still sifts through your nighttime. The afterglow of a universe learning its first steps in bright unsaying. You turn the image in your hands. Like a smooth stone, 2 particles enter, 2 photons leave. Nothing is wasted. The ledger balances. Even their directions add to a quiet bookkeeping. The light flies apart, so the total push is 0. As if the universe prefers its dancers to end where they began. You feel comfort in this tidiness. You also feel the ache of its implication. If every meeting ends in light, then twins would erase each other endlessly. There would be no atoms to cradle, no planets to stand upon, no you to think these thoughts. The world you love depends on the rarest of unbalanced endings, a leftover, a particle that never met its match. But set aside the leftover for now. Rest inside the encounter itself. It is more gentle than the word collision suggests. In your life, collision means dent and damage. Here, collision is a ribbon that when matter and antimatter meet, they remove each other's separateness. What remains is not ruin. It is the possibility to travel, to warm, to illuminate. Photons rush out as messengers, swift as anything can be, carrying away the exact measure of what was once held in mass. You can think of each annihilation as a translation. Solid becomes syllable. Particle becomes pulse. You allow the room to dim further in your mind, and you see faint streaks, as if fireflies were writing in an unfamiliar alphabet. In space, high energy rays cosmic, rays mash atoms and carve positrons out of the storm. Those positrons wander until they meet matter and bloom into light again. In hospitals, a subtler rain of positrons maps the body's inner chemistry. The blooming light tells doctors where cells are most hungry. The act that once sounded like extinction becomes a lanterner, precise, tender lantern that reveals without cutting. An end is, again, a beginning. You keep breathing. The world shrinks to the point where touch happens. At that scale, there is no color, no texture, only fields and their agreements. Attractive, repulsive, quantized steps, conserved accounts. You do not memorize. You listen. Conservation means the universe keeps its sum. Symmetry means it keeps its shape. Annihilation means a neat swap of format mass for light with no secret surplus in the drawer. In this way, the cosmos hums like a well-kept instrument, and the note of each meeting is carried forward in rays that thread through space. Sometimes for billions of years, sometimes just to the detector on a table beside a patient at dawn. You wonder, softly, why this gentleness holds such power. Perhaps it is because you know endings. You have watched days dissolve into evening, plans into memory, seasons into quiet ground. You have learned that endings can be luminous when they are honest. So you let the particles teach you a manner of ending that feeds the future. Become what can travel, become what can share. Become a brightness that does not hoard its heat. There is another hush to notice. Annihilation is symmetrical. If you could reverse the film, those photons could become a pair, a gain electron and positron born from light. This is not fantasy. It is allowed. Under the right conditions, energy precipitates into matter and antimatter like frost forming from invisible chill. Creation and vanishing are two doors on the same hallway. You walk it at bedtime too. You dissolve into sleep, and in the morning you precipitate back into shape. The universe repeats itself in you. Now lean closer to the practical heart of the meeting. In a detector, two photons leave in opposite directions, each with energy equal to the particle mass it inherited. They keep the ledger, balance momentum, spin, charge, now none, all accounted for. Instruments arranged like listening circles catch the outgoing light and triangulate the place of vanishing. When those circles surround a body, they can trace the interior's hungry chemistry. When they surround a vacuum trap in a physics lab, they trace the behavior of shadow atoms made from antimatter, held for an instant like rare birds. In both cases, the same principle sings. Endings are measurable. Their light is a map. You may ask, quietly, whether annihilation is dangerous. It is exact, not cruel. A gram of antimatter meeting a gram of matter would pour out more energy than your days can easily dream. But in nature near you, annihilation is sparse and small. And in clinics, it is carefully tamed, a dusting of positrons, a whisper of photons, a gift of clarity. The cosmos keeps its larger fires mostly in distant vaults, where particle storms sketch delicate lightning across interstellar dark. Return now to the early sea. For a while, everything was meeting and vanishing, a rush of light born from balance. But balance did not last. Somewhere, in a mechanism you will follow later, like a thread through cloth, the symmetry tilted. A fraction of matter remained without partners, like dancers left on the floor when the music pauses. That fraction drafted the future. Atoms combining, stars assembling, galaxies twining into filaments, a sculpture of leftovers, an architecture of almost nothing. You live inside that almost, yet even in a matter-made world, pockets of annihilation glimmer. Where certain radioactive elements sit, a positron may be emitted, slip a short distance, and meet an electron. A tiny pair of photons walks away, hand in hand, invisible to your eyes, yet plain to careful glass. Where space rays cleave through the upper atmosphere, short-lived twins appear and depart in flecks of light. And in the hearts of certain experiments, antiprotons and positrons are coaxed into orbits to form antiatoms, as delicate as frost lace, before they, too, find their way to brightness. You let one more picture open, gentle and exact, two circles on a page, touching. Label one what is, the other what undoes it. Their overlap is not a wound but a lamp. You are invited to live like that lamp when you can transform endings into messages. Turn closings into illumination. Let release be a road for warmth. The particles know no metaphor. They only obey. You carry the metaphor because you can. You are the one who can listen to the light and call it kindness. Time settles. Your breath is even. The idea is simple now. In the universe's first minutes, annihilation was a tide. In your present moment, it is a language, medical, astrophysical, experimental, by which the universe and your body exchange information. Mass becomes message. Message becomes map. Extinction becomes expression. And you, a being of matter in a matter-favored world, rest easier knowing that, even where things end, nothing is squandered. Let your eyes close further. Imagine a last, small meeting at the edge of sleep. A positron slips toward an electron, and together they exhale to quiet rays. Those rays do not ask permission. They go. They travel through whatever darkness remains between where they began and where they are needed. Somewhere an instrument reads them. Somewhere a star's outskirts absorb them. Somewhere they become part of the soft background hiss that has sung since the world was young. You listen, and in listening, you glow a little too. You breathe gently, carrying with you the hush of annihilations, particles and antiparticles meeting, vanishing into light. You have seen their dance, brief, exact, luminous. Yet as you rest deeper, a quiet question rises. If the universe began with equal twins, where is the antimatter now? Close your eyes and drift into the first seconds after the Big Bang. Matter and antimatter were born together, equal halves of a perfect equation. For every electron, a positron. For every proton, an antimatter. The symmetry was astonishing. And yet, in your night sky today, you do not see twin galaxies of antimatter. You do not breathe antimatter air. You live in a world of matter only. Somewhere, balance was broken. Scientists call this puzzle the baryon asymmetry problem, the mystery of why matter won. According to the rules as we know them, the universe should have annihilated itself. Each particle should have met its twin, vanishing into photons, leaving behind nothing but endless light. Yet here you are, built of atoms, resting on a planet of stone, gazing up at stars of fire. Something tipped the scales in favor of matter. You breathe into this paradox. The tiniest imbalance shaped everything. Out of billions of particle and particle pairs, only one extra matter particle remained. One survivor for every billion That tiny excess became the seed of all galaxies, all stars, all worlds, all life. Without it, the cosmos would be empty, silent, radiant with nothing but stray photons. You drift into the thought of loss. Imagine a mirror shattered, one side gone, only fragments left behind. That is the universe's story. A symmetry written, then broken, leaving one side stronger. Antimatter is not destroyed completely. Traces appear in cosmic rays, in laboratories, but the vast half that should exist is missing. It is a silence that echoes in every direction. Why? The question lingers. Scientists search for answers in the laws of physics themselves. Perhaps matter and antimatter do not behave exactly the same. Perhaps the mirror is not perfect. In certain decays of particles, researchers have seen tiny violations of symmetry, small preferences for matter over antimatter. Could those preferences, magnified in the early universe, have tilted the balance enough to create a cosmos of matter? The evidence is faint, delicate, like whispers in static. But it suggests the mirror was never flawless. You rest in this subtlety. The universe was not perfectly fair, and that unfairness, that bias for matter, is the reason you exist. The missing half became possibility. Imperfection became creation. The night deepens. You imagine an alternate universe where balance remained perfect. In that world, every particle found its twin. Every atom vanished. No galaxies formed, no stars lit, no planets spun. Only an ocean of photons would drift forever, silent and sterile. It would be a universe of pure light, but no eyes to see it, no minds to wonder, no hearts to rest in its glow. And so you breathe with gratitude for asymmetry. The missing half of the universe is a mystery, but it is also a gift. Scientists search the cosmos for hints of antimatter galaxies. If they exist, their collisions with matter galaxies would create borders of annihilation, glowing with high-energy light. Yet no such borders are seen. The universe is strangely one-sided, a cosmos of matter. Antimatter's absence is nearly absolute. The chapter softens, holding you in its paradox. You drift between presence and absence, between what is and what should be. The missing half of the universe may never be found, but in its absence lies everything you know. You lie still, breathing into the quiet, carrying the echo of the missing half of the universe. Antimatter, meant to balance matter, has nearly vanished, yet not completely. For even now, across the silence of space, tiny messengers arrive. They fall upon Earth not as armies, but as whispers, faint and rare. These are cosmic rays, particles born in distant stars, supernova and galaxies, carrying with them traces of the universe's hidden symmetry. Close your eyes and imagine the cosmos as a vast ocean, restless and eternal. From its storms, high-energy particles are flung outward, protons, electrons, and sometimes their mirror twins, positrons and antiprotons. They travel for millions of years, crossing galaxies, threading through magnetic fields, until at last they touch the upper air of your world. When they do, they spark tiny showers of secondary particles, cascades of light and energy that rain invisibly upon you every moment of your life. You feel no danger here. These cosmic rays are faint, softened by atmosphere, mostly unseen, and yet, among them, sometimes are traces of antimatter. Positrons drifting down, antiprotons appearing like rare fireflies. They are not remnants of some antimatter galaxy, at least, not that we know. Most are born in collisions, where cosmic storms create brief twins. Still, their presence is a reminder. The mirror has not fully disappeared. Its glimmer remains in every shower of cosmic rain. You drift into this thought. The sky above you is not silent. It is alive with invisible arrivals. Every second, particles born in distant explosions touch your atmosphere. You walk always in their rain. And when scientists build detectors high on mountains or loft them into orbit, they can catch these faint sparks, reading them as clues. Experiments like Pamela, AMSO to aboard the International Space Station, and many others watch carefully, counting positrons, tracing their energy, searching for patterns. Some of those patterns are puzzling. More positrons than expected, rising with energy. Could these be whispers of dark matter decaying, or simply cosmic storms more abundant than imagined? Each possibility carries mystery, and in the search, the universe feels less silent. You breathe softly, letting the image grow. Imagine a positron falling toward you, the twin of an electron. It drifts through magnetic fields, bends and spirals, resists straight lines. It was born perhaps in a supernova, where a star's death created a furnace hot enough to forge antimatter twins, or perhaps deeper, from an unknown process in the dark matter sea. Its journey is long, its arrival quiet, and when it meets matter, it vanishes into light, just as it did in the universe's first seconds. Even now, annihilation continues in every cosmic spark. You pause, sensing the paradox again. Antimatter is gone on cosmic scales, yet it is always being born anew. Collisions make it, stars create it, cosmic rays carry it. It never builds galaxies, but it never fully disappears. Its traces keep arriving, as though the universe refuses to let go of symmetry entirely. You rest with this comfort. The missing half still speaks. You may never see antimatter stars in the sky, but in the rain of cosmic rays, the shadow twins remain. Their numbers are tiny, their lives brief, but their message is simple. The symmetry was real, and its echo continues. The night deepens. You breathe into the rhythm of arrival and vanishing. Cosmic rays fall, antimatter touches matter, light blooms. The story is repeated endlessly, softly, invisibly, as Earth orbits beneath the rain. It is not silence. It is a quiet song of balance remembered, and as you drift, you sense the next turn in the story. Cosmic rays bring whispers, but the true search for antimatter happens in careful laboratories, where scientists trap positrons, create antiatoms, and hold shadows long enough to study their reflection. From the vast cosmos to small chambers of light, the journey continues. You rest beneath the soft weight of night, carrying with you the whispers of cosmic rays, faint traces of antimatter falling upon Earth like invisible rain. But those whispers are not enough. To truly know antimatter, to touch its reflection, humanity has built its own spaces of creation, laboratories of shadows, where the universe is remade in miniature. Close your eyes and imagine such a place. It is not grand like a galaxy or fierce like a supernova. It is quiet, deliberate, filled with instruments more delicate than any stringed harp. Coils of magnets hum, vacuum chambers gleam, lasers thread beams of light through the silence. Inside these chambers, antimatter is not a myth. It is born, it is trapped, it is studied at CERN, the great laboratory in Europe. Scientists accelerate protons until they smash into targets, their collisions bursting into showers of particles and antiparticles. Among them, antiprotons appear, shadows of the proton, carrying opposite charge, yet the same weight. Caught in magnetic fields, they are slowed, cooled, and guided into traps where they can linger, fragile but real. You drift into this image, a trap that does not touch, because antimatter, if it touched ordinary matter, would vanish in light. So it must be held in invisible cages, magnetic bottles that use fields instead of walls. Within them, positrons and antiprotons can be brought together, forming the simplest antiatom, a mirror hydrogen with a positron orbiting an antiproton. For moments, these antiatoms float, free of contact. Scientists shine lasers upon them, watching how they absorb and release light. Do they behave exactly like hydrogen? Or is there a tiny crack in the symmetry, a difference hidden in the reflection? Each experiment is a question whispered into the mirror. You breathe slowly, resting in the delicacy of it all. Billions of years ago, antimatter filled the cosmos. Now, here on Earth, we recreate it atom by atom, holding it in traps no larger than a hand, asking questions as vast as the universe itself. Antimatter has also found gentler homes in medicine. In PET scans, positron emission tomography, tiny positrons are released inside the body. As they vanish against electrons, they create photons that reveal the inner workings of cells, showing doctors where tissues burn energy, where disease may hide. Here, annihilation is not destructive but illuminating, a gift of clarity. And yet, in laboratories, Antimatter is more than tool, it is truth-seeking. Experiments like Alpha and OTRAP study how antihydrogen behaves in magnetic fields. Does it fall with the same gravity as matter? Does it glow with the same spectrum of light? Each test is a chance to peer deeper into the broken symmetry of the cosmos. You pause, letting this patience settle into you. Antimatter is rare, fragile, fleeting, and yet, in these laboratories of shadows, it becomes a partner again, dancing for moments in fields of light, reminding us of what was lost in the universe's first seconds. The night deepens as you drift into these chambers in your imagination. You see the quiet glow of monitors, the hum of magnets, the stillness of scientists watching particles that cannot be touched. It feels almost sacred, a modern temple to symmetry, built not of stone but of fields and beams. And as you rest here, you feel the story turning. If antimatter behaves as matter does, if its reflection is nearly perfect, what about the one force that rules everything, gravity? Does antimatter fall the same way as you do? Or does it rise? The question waits, quiet but profound. You breathe slowly, carrying with you the hush of laboratories, where antimatter is born and held like a fragile flame in invisible cages. The experiments are careful, delicate, and full of awe. Yet within those chambers lingers one question more profound than any other. How does antimatter fall? Close your eyes and imagine holding a feather. You let it go. It drifts down, pulled gently by Earth's gravity. You know this motion so deeply you do not question it. Everything falls. You fall, raindrops fall, stars bend light with their mass. Gravity is universal. And yet, when you think of antimatter, the shadow twin of all matter, the question rises, does it fall in the same way? Or does it rise, as if pushed by an invisible hand? Scientists call this the question of gravitational symmetry. If matter and antimatter are perfect reflections, then antimatter should fall downward like everything else. But if the reflection is broken, even slightly, antimatter might behave differently. The answer is not only about falling, it is about the deepest structure of the universe, whether gravity itself treats matter and antimatter as equals. You drift into the silence of experiments. In the Alpha experiment at CERN, antihydrogen atoms are created and held in magnetic traps. Slowly, carefully, the traps are released. The question is simple. Does the antimatter atom fall down, or drift upward, or hover differently? Early results suggest symmetry. Antimatter falls like matter, and yet scientists remain cautious. Precision takes time. Even the slightest hint of difference could reveal cracks in our understanding of gravity itself. You breathe gently, feeling the patience of this work. Imagine trying to weigh a shadow. Imagine releasing something that vanishes the moment it touches the world. This is what scientists attempt with antimatter. They measure not by holding it in scales, but by watching its faint escape, reading its subtle motion as it drifts in gravity's field. The thought lingers. What if antimatter did fall upward? It would overturn the foundation of physics. It would suggest a universe more strange than imagined, where symmetry is broken not only in particles but in space and time itself. Perhaps antimatter galaxies exist, separated from matter by repulsion, never touching, never annihilating. Perhaps the cosmos is balanced in ways still hidden, but for now, the evidence leans towards sameness. Antimatter, like matter, falls down. Shadows follow the same pull as substance. Symmetry holds, or at least, it does not break here. You pause, resting in this balance. There is comfort in sameness. If antimatter fell differently, the universe might be torn apart by imbalance. Instead, it seems gravity embraces both halves alike. The shadow and the substance fall together. And yet, even in this comfort, the mystery remains. Scientists continue to test, to refine, to release antiatoms again and again, seeking the slightest difference. For within the smallest crack in symmetry may lie the key to new physics, to understanding why matter survived, why the universe exists, why something came from nothing. You drift deeper, breathing with the pull of gravity itself. It holds you now as surely as it holds the stars. It is the quiet embrace of the cosmos, keeping you tethered, keeping the earth wrapped in atmosphere, keeping oceans bound to their shores. And it may hold antimatter too, shadows falling with the same grace as light. The night grows still. You rest in the pull of gravity, not as a burden, but as a lullaby. The earth holds you, and perhaps it holds your shadow twin as well. And as you drift, you sense the next story waiting. If antimatter can be held, studied, and even weighed, it can also be used. In the hands of medicine, positrons already heal. In the dreams of explorers, antimatter may one day fuel journeys to the stars. The story flows now from falling shadows to the gifts they bring in light. You breathe slowly, carrying with you the hush of gravity's pull, steady and soft. Now the story turns inward, away from galaxies and laboratories, into the body you inhabit. For antimatter is not only a cosmic riddle, it is also a tool of healing, a light that looks within. Close your eyes and imagine a hospital, quiet in the early morning. Machines hum softly, lights glow faintly, footsteps echo in polished halls. In one of these rooms rests a device that uses antimatter not for destruction, but for clarity. It is called a PET scanner, positron emission tomography. Here, tiny amounts of antimatter are created in the form of positrons, the twins of electrons. A patient receives a trace of material that releases these positrons, which drift only a short distance before they meet electrons in the body. When they touch, they vanish into two photons, flying in opposite directions. Detectors around the patient catch these photons, tracing their paths, building a map of where the positrons were born. You breathe with this image, annihilation not as an end, but as a lantern. From the vanishing of positrons comes light, and from that light comes vision. Doctors see where cells are most active, where energy burns brightest, where illness may hide. Cancer cells, often hungry for sugar, glow more brightly in these scans, revealing themselves long before symptoms appear. You drift into the paradox again. What once sounded like destruction becomes medicine. What once seemed like the universe's strangest shadow becomes a gentle ally. Antimatter, when handled carefully, shows us ourselves more clearly than mirrors. The night deepens. You imagine lying in such a scanner, still and calm. Around you, detectors hum, tracing the light of vanishing twins inside your body. You feel no pain, only the quiet knowledge that you are being seen, not from the outside, but from within. Antimatter becomes a translator, turning the chemistry of your cells into images that guide healing. And this is only one gift. Scientists imagine more. Could antimatter one day target tumors directly, delivering its energy precisely to sick cells while sparing the healthy? Could the controlled annihilation of particles provide medicine with sharper tools, kinder treatments? The possibilities glimmer like distant stars. You pause here, breathing into gratitude. The same principle that fills the cosmos with light, the same annihilations that shaped the early universe, now guide doctors' hands. In each photon released from a positron's vanishing, there is not loss, but help. Antimatter in medicine is a reminder of something larger. The universe is not only vast, it is intimate. Its laws are written in galaxies and in cells alike. The symmetry that broke at the dawn of time is reborn here in tiny moments, helping life endure. The chapter slows, inviting you to rest in this paradox. The universe's strangest twin becomes healer. Its most mysterious transformation becomes a tool of kindness. You rest with the thought that science, at its best, turns mystery into care. And as you drift, you sense the next step. If antimatter can heal, it might also power. The energy of annihilation, so pure, so complete, could one day drive ships across the stars. From the body's healing to the dreams of journeys, the story flows on. You breathe gently, carrying the quiet glow of positrons inside the body, healers born of shadows. Now you look outward again, toward the deep dark of space. For antimatter is not only a tool for medicine, it is also a dream of vengeance, a promise of journeys far beyond your world. Close your eyes and imagine a single gram of antimatter, no heavier than a paperclip. If it met a gram of matter, the annihilation would release energy equal to tens of millions of liters of fuel. More than any rocket has ever burned. More than enough to carry ships across the solar system, even to other stars. Antimatter is the most powerful fuel the universe allows. No other process, no fire, no fission, no fusion can match its efficiency. Every bit of mass becomes energy. Nothing is left behind. It is the purest translation, matter into light, substance into momentum. You drift into the dream of explorers. Rockets today burn chemical fuel, heavy and slow. Even nuclear fusion, the power of stars, would still be vast but limited. Antimatter, though antimatter could make the stars reachable within a human lifetime. A ship driven by antimatter annihilation could accelerate swiftly, coast across light years, bring distant suns into reach. You breathe into this vision. Spacecraft with glowing thrusters, golden streams of photons and particles blasting into the void, carrying fragile travelers into interstellar dark. It feels like science fiction, and yet it rests on the most real law of physics. E equals mc, energy stored in matter, released completely by its meeting with its twin. But you pause, sensing the paradox again. Antimatter is powerful, but fragile. To hold it is to hold a flame that annihilates upon touch. It must be stored in perfect traps, away from every atom of matter. Even a speck meeting the walls of its container would vanish in a flash. This makes antimatter fuel not only a dream, but a danger, a light wrapped in risk. Scientists have tried. Particle accelerators create antimatter, but only in tiny amounts, far less than a grain of dust, at enormous cost. To gather enough for engines would require mastery not yet reached. Still, the dream endures, because in that dream is freedom from limits. The stars, long distant, suddenly come closer. You drift deeper into the thought of journeys. Imagine a ship leaving Earth, powered by antimatter. It arcs past the planets, leaving behind the blue glow of home. It accelerates, faster than any rocket before. Within decades, it nears another star. Explorers look back at the sun, small and pale, and forward at a new sun rising ahead. All of it possible because of the hidden symmetry, the annihilation of twins. You pause in stillness, feeling both hope and caution. Antimatter is ultimate efficiency, but it is also ultimate responsibility. It asks of us precision, control, wisdom. To build engines of the future is not only to master physics, but to master ourselves. The night grows deeper. You rest in this paradox: antimatter as healer, antimatter as engine, antimatter as light, both tender and fierce. From the body's healing to the dreams of journeys. Its story spans both the most intimate and the most infinite. And as you drift, you sense the next chapter waiting. Beyond fuel and fire, beyond engines and dreams, lies the mystery itself. For antimatter remains unfinished, its questions unsolved. Symmetry broken, shadows missing, yet traces enduring. The story moves now into reflection, into resting within the mystery itself. You breathe slowly, carrying with you the echoes of engines glowing in the dark, the dream of journeys powered by annihilation's light. And now, as the story nears its end, you drift away from rockets and laboratories, away from galaxies and cosmic rays, into a softer place. Reflection. Antimatter has been a thread through the universe's story. From the first instant of creation to the instruments of healing, from fragile laboratory traps to dreams of the stars. Yet it remains a mystery. Why did symmetry break? Why did matter survive, leaving antimatter to fade? Why is the universe you see made from one twin when both were born together? Close your eyes and imagine the mirror once more. On one side, matter, stars, galaxies, planets, you. On the other side, antimatter, a reflection faded, a presence missing. The mirror is cracked, but not gone. In cosmic rays, in PET scans, in delicate laboratories, the reflection returns for moments, enough to remind you it is real. The symmetry is not complete, but it is not lost either. It lingers like a half-heard melody. You drift deeper, breathing into the thought that imperfection created everything. If the symmetry had held, the universe would be light alone, a pure brilliance without form. But because the balance tilted, matter remained, stars formed, life began. You exist because of broken symmetry. Creation required imbalance. Beauty required imperfection. You pause, resting in this paradox. Perfection, so often imagined as the highest state, would have left nothing. It is the flaw that gave rise to galaxies. The crack in the mirror became the window through which the universe emerged. You, too, are part of this. Your life, like the cosmos, is shaped by imbalance, by asymmetry, by imperfection. And yet, in those imperfections, there is wonder. Scientists continue to search, patient and careful. They measure the glow of anti-atoms, weigh their fall, listen to their light. Each experiment is a quiet question. Does symmetry still hold, or does it hide secrets deeper than we know? Perhaps the answers will come. Perhaps they will remain just beyond reach. But either way, the wonder is not lessened. Mystery itself is a gift, a reason to keep looking, a reason to rest in awe. The night deepens. You breathe into stillness. You see the symmetry not only in physics, but in yourself. Breath in, breath out. Wakefulness, sleep. Presence, absence. You are a mirror, too, one side matter, one side shadow. You live in the balance of opposites, in the endless dance of dualities. The story of antimatter is not finished, and perhaps it never will be. But tonight, you need no final answer. It is enough to drift in the rhythm of wonder, to rest in the mystery that is both intimate and infinite.